Eunice, we can start. So when I look on the regression and correlation analysis, we are saying that regression analysis is just a statistical technique that is going to be checking the, or is going to be studying the relationship that is existing between two variables. So some of the assumptions which are normally tested in an exam, we normally have linearity. And you are going to be forming our equation in form of y is equals to a plus bx. When you advance to intermediate, you will be able to cover this under management accounting, whereby we are going to be elaborating further how the regression is part of the cost estimation. There is a topic of cost estimation there up. So that is where we are going to be saying that during that time that the organization will be able to look on a formula that is going to be assisting them or assisting the organization to be able to assisting the organization to be able to predict and project the total cost in which they have to incur. So during that time, we will be able to define what is our Y, which basically is our total cost. In other terms, because later on we shall do functions, when you look on our Y is dependent, it is dependent because it is a dependent variable considering that when you are going to be buying a product, remember you are an organization that already knows how much they normally pay in terms of rent, which basically is our A, which is fixed costs. Then we have a variable cost per unit. How much are we going to be purchasing one product? And that is why we have to be defining what is the number of the units. So my X will be basically mean, that is my dependent variable. So every time the total cost, basically, I normally analyze it like it is a simple cost which you have already allocated that you need to apportion to the number of the units that you need to invest to the number of the unit that you want to produce. Now, when you look on number 2, we are saying there is no auto, which is a serial correlation between the variables, and we are saying independent variables assume not to have a close relationship. And that is why we talk about independent. They don't depend on any other. So it means that we are not going to be having that case again. So independent will be one product will not be able to depend on the outcome of the other product. Now, when we look on number 3, we are saying there is no multicollinearity, and we are saying predictor variables which are used in multiple regression are not significantly related, and we are saying that note number 4, the error terms assumed to be normally distributed, have a constant variance, and have a mean of 0. But what are types of the regression that we normally have? We normally have only 2. We normally have simple and multiple. And basically, when we are discussing about the simple regression, it means that we are going to be forming an equation where we are dealing with only one independent variable. You know that independent variable now is our X. Now, we are saying it is normally used where there is the nature of the cost function is not complex. And that is why we are saying y is equals to a plus bx. And therefore, to get my b, we are going to be taking, we are talking of a formula that we have to be using while we are calculating the questions. Those formulas I will be able to teach you and simplify them, how we should be working on them. So that does not have any problem. I just want to look on, because there are some of the equations that we're going to be coming up with. How do we normally appraise those equations? And we are saying once an equation has been formed, developed, it should be appraised or evaluated for efficiency and reliability. And we are saying that the following methods are basically used. We normally have economic plausibility, goodness of fit test, and then we normally have specification. The first 2 are the ones which are normally tested. And we are saying that under the economic plausibility, for an equation to be used for probability, there must be explainable relationship between the variables. And we are saying there must be a clear relationship which is existing between X and Y. That is where we are discussing about response and predictor variables. Now, when you look on the goodness of fit test, we are saying that because there are data that you're going to be using to formulate these equations, you need to understand that it should fit. Right? The equation formulator should be able to fit the data that you are using. And that is where we are saying it is categorized into two major measures, and we normally have the whole equation measure, where the whole equation measure is basically the coefficient of determination. We normally have coefficient of determination, which is our R squared. I will be able to show you how to calculate them. We have the standard error of estimate, and then we have F statistic. When you look on the slope measure, we are talking about the coefficient of correlation commonly tested there. And remember, our R and R squared, they have a relationship. We should be able to look at when we are doing our questions. And then we have standard error of slope. I will be able to show you how to calculate it. And then hypothesis testing, we shall not do it because it's a topic of its own. Now, when you look on the coefficient of determination, for instance, we are saying that it is a measure which gives explanatory power of the model, and it is used to measure the variation of the dependent variable as a result of the changes in the independent variable. And this information I will be able to give you when we are doing our illustration. So it is important, rather than explaining a lot of these notes, it is good when I have a question at hand. So let us do our question here. Let's look on a question. Let's look on a question somewhere. So let us go to past paper. I just want to do only one question, which is perfect for all the methods there. So let us look on November 2015. I think the question is here. Yes, the question is here. November 2015, question number 3B. So let us meet there. November 2015, question 3B. You can read the question. Read the question kindly.
The table below relates to the number of units packaged by 9 casual employees of BD Limited and the packaging time taken by each of the employees. We have number of units packaged and we have time in seconds. So we have number of units packaged 14, 8, 9, 12, 6, 11,
that is okay.
10.
Just go to requirement. You see number 1, the examiner is saying the regression line of the packaging time against the number of the units, the product moment correlation coefficient, the standard error of estimate, the 95% interval estimate of the regression line. And then we are being told the packaging interval, time interval for 7 units. When you look on this question, it is not a must that the examiner will be able to tell you which one is X and which one is Y. It is upon you to be able to differentiate which one depends on the other. And this is very simple because we are discussing about the number of the units. So the number of the units packaged, you know, that are our independent variables. And then the time that you are going to be allocating on each unit we have to produce will be determining how many units we have to produce at the end of the day. Now, in this case, let us look on the solutions for this question. Let us look for this solution. think it is okay. A minute, please. It is good. So we are looking on this question. So when I want to calculate the question with regression, I just want to put here my X and here my Y. Because number one, examiner is talking about coming up with a multiple with an equation that will be able to fit that data. So I just copy my data here. So I have 14. We have 8, right? We have 9. We have 12. We have 6, 11, 10. And then we have 5, 10. Then for Y, we have 230, 110, 130, 190. We have 109, 109, 181, 181, 154. We have 79. And then the last one is 144. It looks like that. So in this case, I know the first thing that is the examiner wants. He wants me to get, they normally use the name like least square, least square regression. This basically normally means simple regression. Simple regression is just like that. So we are saying that we are formulating our equation in form of y is equals to a plus bx. So basically, you know that your y will be the total cost. In other terms, you can call it dependent variable. Dependent variable. We have our x, which we are discussing about it being the number of units produced. The number of units produced, or you can call it independent variable. Then we have our A, which is the total cost, total fixed cost, sorry. This is my total fixed cost. Then my B here, which will be equal to, B will be the variable cost per unit. The variable cost per unit is our B. Now, in this case, I just need to understand very well that to get my B, I normally use a formula. So my formula is N, the summation of XY, minus summation of X, summation of Y. We divide by N, the summation of X squared, minus summation of X, you close your bracket squared. Then to get your A, you normally take the summation of Y, minus B summation of X, then we divide by N. So when I look on my formulas here, I need to multiply X and Y here. And then we normally have X squared here. And because I don't have a lot of time, I just want to show you how you have to deal with this in exam. Just go to that calculator of yours. You press mod, choose regression, and then we are forming linear equations. We are forming linear equations. I remember I was able to teach this when you are doing another topic there. I don't know whether you have done time series, I don't know. So our mod, which is, it will be able to tell me that there are 3 components there, but I'm very much concerned with regression. And then when I press regression, it will bring another information there, but I choose linear. I want linear. I press 1. So calculator pale juu itakuwa na reg. Umefanya hivyo? Eunice, have you done that?
Not yet.
Do you have your calculator?
Yes.
Have you pressed mod?
Yes.
What does it indicate?
Imeleta 1 com, alafu 2, 3 ni regression. Sasa nifinye 3.
Ufinye 3.
Yes.
Haya, inakuletea nini?
1 ni linear.
So we need number 1, which is linear.
Okay.
So calculator pale juu ime already display reg, ndio?
Yes.
So I want to feed this data in a calculator. So I will take 14, 230, and then I press M plus. Tuanze ya kwanza, 14. Do you see comma where it is?
Yes.
So comma, 230, and then you press M plus. Calculator displays what?
N is equal to 1.
Very good. Let us go to the second one. 8, 110. M plus again. Calculator displays
2.
Good. 9, 130. M plus. 12, 190. M plus. 6, 109. M plus. 11, 181. M plus. 10, 154. M plus. 5, 79. M plus. 10, 144. M plus. Calculator and display ini. Calculator displays what?
N is equal to 9.
N is equals to 9. So ukiangalia data yako 1, 2, 3, 4, 5, 6, 7, 8, 9. Sindio?
Yes.
Imagine you can switch that calculator and when you wake up tomorrow, it will be able to give us data. It will be able to give that data. Now, I just want to look on how do I normally get my summations because they are very important for getting the linear equations. So to calculate or to get these values here, you normally press Shift 1. Shift 1. Ukifinya calculator Shift 1 inakupea nini?
Inaleta summation of x squared.
Press 1 and then equal sign. Calculator imekupea ngapi?
867.
Very good. Unaandika hapo 867. Shift 1 again. 2. 2 is summation of x. We need it. Umepata ngapi?
Sorry, umesema?
Umesema shift again. Shift 1. And then we press 2 because we need summation of x. And then equal sign. How much are you getting?
85.
Naandika hapa 85. Shift 1 again. And then you scroll using this button. The replay button. Scroll utafute hii zingine. So let me scroll. Have you scrolled?
Umesema ni scroll to which side?
This side.
Okay.
What have you seen?
Summation of y squared.
But tuna haja nayo lakini tuko na number na summation of y, ndio?
Yes.
Which is number 2 equals sign. How much are you getting?
1327.
1327. Then the last one, you go again, Shift 1. Then you go to number 3. Have you scrolled to the end?
Yes.
What can you see?
Summation of y squared. And
so we need number 3 because it's the one that is missing here. We need number 3, then equal sign. How much are you getting?
13,570.
Very good. 13,570. Sasa unajua hii data mimi sija feed. But mimi naendelea na swali yangu because I'm doing my exam. So hapa nakuja nasema to get my B, nachukua my N. N uliniambia ni 9. times the summation of xy, tumepata 13,570, minus the summation of x, 85, summation of y, 1327. We divide by n, which is 9, summation of x squared, multiply by 867, summation of x, this one, it is 85 squared. So, ndio nipate this answer, I will press shift 2, and then I scroll it after B. Shift 2, let me scroll to the far end. Have you seen B? Have you seen B?
Not yet.
Shift 2, scroll to the end.
Naona A, B, R.
So press 2. And then equal sign. Your B is how much?
16.15.
So my B here is 16.15. Then our A is equal to summation of y, which is 1327, minus our B, which is 16.15, times summation of x, which is 85. We divide by 9. Go again, shift 2, alafu utafute A. How much is your A? How much is your A?
-5.
Negative
5.08.
5.09. So to form my equation, I say y is equals to negative 5.09 plus our B, which is 16.15x. Have you understood that point? These are our equations that the organization will be able to use. These one.
Yes.
Good. So already we have answered part 1, which is 6 marks. So I know you're asking me, what about these? These ones you normally come and do step back. After ushamaliza maswali, usishinde hapo ukimultiply it. Just leave it, then later on, ukishamaliza your exam, just come back here. And then you do the multiplication. It is normally basically, that method is basically used to save time. What about the last requirement exam? The last one. The last requirement exam. The last requirement examiner is saying what? Eunice.
Yes.
Can you see the last requirement? Requirement number 5. Requirement number 5. Examiner anakuambia the packaging time interval for 7 units. So anakuambia packaging time interval for how many units? 7 units. Remember already you have generated your equation here. So which is y is equals to negative 5.09, right? Plus 16.15. But now the examiner is giving you, because you know this, our x are units, and the examiner out of the equation that you have formulated, I'm going to compare the value of x, which is 7 now. So anakuuliza, what is the packaging time now? What is the packaging time? How much is this? How much are you getting? Eunice, are you together?
Yes.
So what is the answer?
My answer is 107.96.
Equivalent to 108, senior. 108. Yes. Remember, niko na 8 marks so far. 8 marks. I have 8 marks so far. Then from there, we proceed to the other requirements. I just want first to do the coefficient of determination using these illustration. Just want to do the coefficient of determination. So I just here come and I write for you coefficient of determination. Which is our R squared. So to get your R squared, unachukuanga explained. Explain variance. We divide by the total variance. We divide by the total variance. So in simple terms, I just need to take the summation of y predicted minus y mean squared. We divide by the summation of y minus y mean squared. Good. So in this case, this is our y predicted. What about this one is our mean? Then this one is historical, the one given by the examiner. The one given by the examiner. So how are we going to be getting our mean? So my mean will be, I take the summation of y, which is 1327. 1327 divided by 9, how much it is? 1327 divided by 9?
147.4.
147?
Yes.
Point what?
Point 4.
0.4. So remember this y predicted tunatumia equation yetu. Equation yetu. So equation yetu ilisema inakaaje? Equation yetu ilikuwa aje? So ilikuwa y is equals to negative 5.09 plus what?
Plus 16.15.
16.15x. So you just come and you feed it, yeah? You say to get my y predicted, I will take 5.09 plus 16.15x. Now, remember you have the x values here to predict or determine your y predicted, right? So how much is that? So how much have you gotten for the first one? Remember, this is negative. Considering that this is negative 5 points. This is negative. How much? The first one? Remember you have your x here. So the first one will be, negative 5.09 plus 16.15 times, wait a minute, kuna kijana hapa hataki kunyamaza. So it is negative 5.09 plus 16.15 times 14. The first one is, upata ngapi? 221. The second one?
Yangu nimepata 220.2.
So we have said negative 5.09 plus 16.15 times 14. So 221. The second one we multiply by 8. The second one, when you multiply by 8, how much are you getting?
124.1.
0.11. The third one? 140.26. The other one is 188.71. The other one is 91.81. This is 172.56. Then we have 10, which is 156.41. The other one will be
75.66.
75.66. And then the last one? Last one is 156.41.
Yes.
Is it like that?
Yes.
From there, now let us do our explained variance, because already I have y predicted. So I just want to take my y, because you see here it is y predicted, which you have already gotten, minus your mean. So it means I need a column here. So the column that I'm going to be having, it is for y predicted minus y mean squared. So the first one is considering that our mean is 147.44. So I take 221.01 minus 147.44. Then I square. I'll be able to get something closer to this, 5412.54, right? The second one will be 124.11 minus 147.44 squared, which is 544.89. The other one is 140.26 minus 147.44, right? I'm getting 51.55. The other one will be 188.71 minus 147.44 squared. We are getting 1703.21. Then I take 91.81 minus 147.44. And I will be able to get 30. It should be 3094.70. Then the other one is 172.56 minus 147.44 squared, which is 631.01. Then the other one is 156.41 minus 147.44 squared, which is 80.46. 75.66 minus 147.44 squared. I'll be able to get 5152.37. Then the last one will be 156.41 minus 147.44 squared. I'll be able to get 80.46. That already we have gotten the explained. Then I need to get the total variance, which we said we normally use the y historical minus our mean, then we square. So I start with the first one, which is 230 minus 147.44 squared, and I will be able to get 6816.15. The other one will be 110 minus 147.44 squared. I'll be able to get 1401.75. Right? We have 130 minus 147.44 squared. We'll be able to get 304.15. Then we have 190 minus 147.44 squared. I'll be able to get 1811.75. 0.35. Then we have 109 minus 147.44 squared. It is 1477.63. Then we have 181 minus 147.44 squared. I'll be able to get 1126.27. Then we have 154 minus 147.44 squared. We get 43.03. Then the second last we have 79 minus 147.44 squared, which is 4684.03. Then the last one is 144 minus 147.44 squared. I will be able to get 11.83. So I need the totals there. So let me add this where ni adi ingine. So we have 5412.54 plus 544.89 plus 51.55 plus 1703.21 plus 3094.70 plus 631.09 plus 80.46 plus 5152.37 plus 80.46. Mimi yangu nimepata 16751.19. Yako umepata ngapi?
In a minute nakupatia jibu.
Sorry?
Kidogo tu nakupatia jibu.
Sawa.
Yangu nimepata 17. 676.19.
10. 19. So to get our R squared, unachukuanga nini? Nakuja hapa nasema, I normally take explained variance, which is 16,751.19. We divide by 17,676.19. How much it is? I'm getting 0.94, right? .94, I'm at 0.95. It is okay. Iko sawa?
Yes.
Now, when I have R squared and the examiner is asking for Carl Pearson's correlation coefficient. Remember, this is our R. So to get your R here, I need to do what? Am I supposed to root 0.95? How much are you getting? How much are you getting? Sorry? How much are you getting?
0.
I have said you have R squared, which is coefficient of determination, which is 0.95. Now, examiner amekuuliza Carl Pearson correlation coefficient, which is our R. So it means that I need to root this R squared to get R. How much are you getting?
I'm getting 0.9.
0.97. Ni sawa?
Yangu ni 0.94.
0.94 ndio hii, which is our R squared. It is 0.95 actually. Ukiruti hiyo anza unapata ngapi? Ndio upate R.
0.97.
Yes, that is what I mean. So kama examiner ameniuliza kwa hiyo swali, the product moment correlation coefficient. So already nishafanya coefficient determination. I can use that shortcut to get the correlation coefficient. That is how you normally do it. Have you seen it?
Yes.
Now, I want us to do the other model, which is called the Carl Pearson, because now I want to work on it. I think these answers, you have to factor them somewhere because we shall be able to use them. So we shall be able to use them because the examiner normally asks you about R squared interpretation. R squared interpretation. And you say, when R squared is falling between 0 to 0.49, we say the model is weak. Between 0.50 to 0.59, we say the model is average. The model is average. Then we have 0.60 to 0.74. We say the model is good. Then when it goes above 0.74, we say the model is very good for prediction. The model is very good for prediction. So that is what we have to factor. So kama hapa examiner angeniambia ni interpret my results, I would say that because it is 0.95, which is above 0.74, I say the model is very good for prediction. The model is very good for prediction. That is one case scenario. I want also to calculate, I have said, let me work on this data to get, what am I supposed to be getting here? I should be able to calculate the standard error. The standard error of estimate, where we say the lower the error, the better the model. So, not feeling okay. So here we are talking about the Carl Pearson's, the standard error of estimates. The standard error of estimates. And in this case, you say, to get my SE, we are going to be taking the root of unexplained variance. Unexplained variance, we divide by degree of freedom. Degree of freedom. Are we together at that point?
Yes.
So I told you very well how I will be able to explain to this. To get that, you have to use ANOVA tables, which are basically used to interpret variances. It is used to interpret variances. So here, you normally have to factor your source, stroke type. Source, stroke type. We normally have sum of squares. Then here, we calculate our proportions. So the source stroke type, we are talking about explained variance. The other one is unexplained. Explained variance. So to get the explained variance, then the last thing that you have to sum them, and that is where we have the total variance. So the explained variance, we have 16,751.19. Then the total variance of ours, tulipata 17,676.19. What is the difference? As you get the difference, let me count. So it is 925 flats.
Yes.
Okay, 925. So we are saying here, to get the proportions, these are divided by this, 16,751.19 divided by the total, tulipata 0.95. Senior, 925 divided by the total, we should be getting 0.05. Because the proportions should be equal to 1. The proportion should be equal to 1. So in this case, because I know my standard error, of estimates already. So this is what I have to factor. This is what I have to do. So I'm just saying, to get the standard error of estimates, we are going to be taking the root of unexplained, 925. Degree of freedom, when you look on n minus k, because this is how we normally get the degree of freedom, your k will always remain as 2, because we are discussing about only 2 parameters, hii na hii. So our k is always 2. So mi ucheza na n. So n yetu ni ngapi? Uliniambia ni 9. So I take 9 minus 2, which is 7. So hapa I divide by 925 divide by 7. How much is this? What is our standard error?
132.14.
You have gotten 132. 925 divided by 7, then you root your answer, you'll be able to get 11.50. 11.50. Umepata kitu kama hiyo?
Yes.
So to get your confidence interval now, we normally take the point of estimates plus or minus. We have to use T or Z, then we multiply by the standard error of estimates. So the point of estimate ni ile tulipata pale chini. Ile tulipata ya 7. Ile tulikuja hapo ukasema but my x is 7. Ulipata ngapi? Negative 5.09 plus 16.15 times 7, you are getting how much? It was 107, equivalent to 108. Sindio? Plus or minus. You know, wakati ulikuwa pale ukisoma probability, we discussed about this too, right? This one is the T-score is basically factored when you are discussing or when you are sampling a data which is less than 30. But this one is basically used when the data is greater than 30. When the data is greater than 30. So nikiangalia swali yetu, data yetu ni less than 30, right? So I will be able to use the T-score. So ndio nitumie T-score nakuja hapa na chora normal curve namna hii. Nikwambie hivi, examiner amekupea 95%. 95%. So the difference which is 5% ni ya hizi tails. The difference na hiyo tail. So 5% divided by 2 ni ngapi? Hapa inapaswa kuwa ngapi? Hapa ni ngapi? So hapa ni 0.025. Hapa ni 0.025. Let me also convert this to 0.95. So because we want to get our T here, nakuja nasema, let me take the values. Let me take one T to incorporate 0.95. So nakuja nachukua 0.95 plus 0.025. How much is this? It should be 0.975. Then you normally match it with the degree of freedom which you got 7. You unaenda kwa table. Tunaenda kwa table sasa. From table. Have you understood?
Yes.
So let us go to the table. we are looking for a T table. So let me search it. Uko nayo?
No.
Just looking for a past paper which has it. Good. So the T-square normally looks like this. The T-table, sorry. The T-table normally looks like that. Can you see mine?
Yes.
So have you seen where we have a difference of 5? Ukiangalia hapa juu hapa. Ukiangalia hapa juu wamekuambia hapa kuna cumulative, kuna one tail na kuna two tails. So the two tails of yours normally total to 0.05. The one tail is 0.025. Then the T that we are looking is 0.975. Sindio?
Yes.
We are looking it against 7. You can see 7 here. So nakuja direct mpaka mahali tumemark. So tunapata
2.366.
365. Sindio? 2.365. 2.365. So it will be like this. So what you are getting, it is 2.365. So that is how we normally do it. So from there, let us continue. So our T is 2.365. Then from that point, we just need to do what? Because I was calculating the confidence interval, which we said is the point of estimates plus or minus T times the standard error of estimates. So it means we are going to be having two answers. Utakuwa na upper limit, utakuwa na lower limit. So the upper limit of mine will be 108, which is the point estimate already we have predicted, plus 2.365 times the standard error yenye umepata 11.50. Here itakuwa 108 minus 2.365 times 11.50. So hapa limit yako ni ngapi? Bana ngapi?
135.19.
135.2. Then the last one. Umepata 80.80. So the information of the confidence interval lies there. Lies there. Lies there. Have you seen it?
Yes.
Now from there we proceed. That is the standard error of estimates. I think you are able to see it. And now you normally get the confidence interval. Examiner was asking for around 95%. You are able to get it. Then what is remaining here is just to calculate the coefficient, the correlation coefficient, F statistics, and the standard error of slope. I did those, and we look on the Spearman's rank correlation. So I will be able to request, because I'm not feeling okay. I can't withstand much. Tomorrow we finalize. Tomorrow we will be able to finalize